Hi guys, today we continue to study chapter 7 about waves. A wave, including light, changes its direction when it strikes on an obstacle or a surface. This type of direction change is called reflection. Reflection by an irregular surface in different directions is called diffuse reflection. Reflection by a smooth surface in one direction is called specular reflection. Due to light reflection, a mirror forms a virtual and upright image. A wave, including light, changes its direction when it enters a medium from one to another. This type of direction change is called refraction. The index of refraction, n, is a physical quantity to measure the ability of direction change, defined by the ratio of light speed in the vacuum and the light speed in the medium, i.e., n equals c over v. Due to refraction, the apparent depth of an object in a medium is given by the real depth divided by the index of refraction. That is, the apparent depth h prime equal the real depth h divided by the index of refraction n. Let's do an example. In a medium, light travels at speed of 1.5 times 10 to 8 meters per second. Find the index of refraction and the apparent depth of an object with a real depth of 6 meters. From the index of refraction formula, n equals to c over v, substituting 3 times 10 to 8 meters per second into c, and 1.5 times 10 to 8 meters per second into v. We have the index of refraction n equals 2. Then dividing the real depth 6 meters by the index of refraction 2, we obtain the apparent depth h prime equal to 3 meters. Lens is a piece of glass that is shaped to produce image by refraction. There are two types of lenses, convergent lens and divergent lens. Convergent lens is thicker in the middle than at its rim. It can bring parallel light to a single point f called the focal point. The distance from the lens to the focal point is called the focal length. The image of a convergent lens is usually real, but upside down. Another type of lens is divergent lens, which is thinner in the middle than at its rim. It can spread out parallel light so that it seems to come from a point behind the lens. This point is also called the focal point, and the distance from this point to the lens is also called the focal length. So lowercase f is focal length, uppercase f is the focal point. The image of a divergent lens is always virtual and upright, but minimized. A camera uses a convergent lens to form a real image on the film. A convergent lens can form a magnified virtual upright image when the object is close to the lens. Like a camera, an eyeball has a convergent lens. A normal eyeball can converge parallel on the retina. Well, a clear image is formed. That's why I can see object. Nearsightedness and farsightedness are two common vision defects of eyes. Nearsightedness occurs when the eyeball is too long, and thus focuses light in the front of the retina. It can be corrected by wearing a divergent lens. Farsightedness occurs when the eyeball is too short, and thus focuses light behind the retina. It can be corrected by wearing a convergent lens. White light is a mixture of different frequency or colors. Seven major colors of visible light are red, orange, yellow, green, blue, indigo, and violet, in the increasing order of frequency or the decreasing order of wavelengths. Red light has a longer wavelength. Violet has a shorter wavelength. And this diagram is quoted by the video frame, so didn't show the indigo below but didn't show the violet below so suppose below the indigo. Separation of light being into various colors or frequencies is called dispersion. A glass prism can disperse light in different color or different frequency. Rainbows are caused by dispersion of sunlight by water droplets in the atmosphere. Interference is a wave or optical phenomenon occurred when two or more waves pass a point at the same time and add together. There are two types of interference: the constructive interference and the destructive interference. Constructive interference occurs when the original two waves are in step. And combined to give a wave of greater amplitude. Destructive interference occurs when the original two waves alter step. So one is increase, one is trial. They cancel each other, and combine to give a wave of a smaller amplitude. Constructive interference make the light brighter. Destructive interference make the combination darker. Due to interference, a colorful pattern can be formed on a thin film when sunlight shines on it. The ability of waves to bend around the edge of an obstacle is called diffraction. When the wavelength is about the size of an obstacle, a significant diffraction is possible. Light can be diffracted by a slit. Sound can be diffracted by a building. So somebody speak in one room, somebody else can listen the sound outside. This is the end of this chapter. Thank you.